Azure Databricks can process massive amounts of data at scale, but raw data sitting in a data lake doesn't drive business decisions. To extract actual value, you have to connect that processed data to presentation layers where analysts can see it. To bridge that gap, Microsoft built multiple integration pathways. You can connect Databricks to Microsoft Fabric for unified analytics, or link it straight to Power BI for interactive reporting. Connecting the tools is the straightforward part. The true architectural challenge is designing systems that share information without continuously duplicating the underlying data across different platforms. Every time you expose a dataset to a new tool, you risk fragmenting your security model. You have to build these connections while keeping Unity Catalog as your single, centralized layer for governance. The specific integration pattern you choose dictates the actual security perimeter of your organization. Fabric reads Unity Catalog tables natively by creating OneLake shortcuts that point directly to the underlying Delta tables in Azure Data Lake storage. This mirroring process copies only structural metadata. Physical data files stay exactly where they are, avoiding any physical data duplication. But this creates a specific security scenario. When Fabric engines query data, authorization checks use the identity of the connection configurator. Downstream Fabric users accessing that shortcut effectively bypass Unity Catalog, as user-level governance policies aren't evaluated for the person actually running the query. The integration works in reverse, too. Data engineers can run complex transformations in Databricks and write the process data directly back to Fabric's OneLake using the Azure Blob File System Diver. If you write to OneLake from Databricks serverless compute, you must authenticate using a service principal. This fixed credential provides flexibility for automated workflows, but removes the ability to track individual user identities. Fabric integrations deliver seamless, unified analytics. To achieve that bidirectional flow, you trade away the fine-grained, user-level tracking that Unity Catalog provides. When moving to Power BI, architects must choose between two primary connection modes, import mode and direct query mode. Import mode physically loads data into Power BI, providing fast queries but requiring scheduled refreshes. Direct query leaves data in place, pushing real-time queries to Databricks. To optimize this, new connections use the ADBC driver, a modern columnar API efficiently moving analytical workloads. Existing ODBC connections won't upgrade automatically. You must open the Power BI Advanced Editor and manually update the implementation to version 2.0 to capture these efficiency gains. Direct query, paired with the ADBC driver, is the required architecture if you want high-performance, real-time analytics without maintaining duplicated semantic models. Rather than analysts manually pulling data into Power BI Desktop, data engineers can now push semantic models directly to the Power BI service. This setup menu in the Databricks Catalog Explorer shows how to initiate that push. As long as the target Power BI capacity has the XMLA endpoint enabled, you select the target workspace, select Direct Query, and publish. During this process, any column comments and technical documentation maintained in Unity Catalog transfer automatically to Power BI. For production environments, these semantic model updates are orchestrated via Power BI tasks directly within Databricks workflows. This workflow graph shows how those tasks integrate. By setting up strict dependencies, the Power BI refresh task on the right will only execute after the upstream data transformation finishes successfully. Orchestrating Power BI tasks within Databricks elevates business intelligence from isolated reporting into a reliable, code-driven data pipeline. The ultimate choice of integration relies on a strict decision matrix driven by your audit requirements. In the Microsoft Entra ID path, paired with Direct Query, Power BI passes the viewer's exact SSO credentials straight through to Azure Databricks. Unity Catalog uses that identity to evaluate permissions, enforcing exact row-level filters and column masks for the individual viewer. Compare that to service principals, the standard method for Fabric shortcuts and automated workflows. Because service principals evaluate permissions based on fixed credentials, the system records only that the service account accessed the data. You lose the ability to track which specific end user consumed the report. Data architects must often trade the granularity of user-level auditing to gain the systemic reliability of automated workflows. Designing the comprehensive Databricks-Microsoft integration architecture requires carefully matching a strict authentication protocol to a highly specific business requirement. When the goal is to publish curated datasets for broad gemerit and assumption across Fabric, deploy service principals, and write data directly to OneLake. When strict user-level Unity Catalog governance and compliance auditing are non-negotiable, you must deploy Power BI Direct Query paired with Entra ID Single Sign-On. Unified data architectures succeed when engineers intentionally design exactly where the data lives and precisely whose identity is permitted to access it.